Welcome, ladies and gentlemen. In this video we're going to take a look at how to actually model threads using SolidWorks. In this video we're actually going to be creating threads instead of just adding a thread call out to either a shaft or a hole. So you need to be familiar with the terms major diameter, minor diameter, thread form, and pitch. Now in this video we're going to create a 1/2 inch 13 UNC thread. So to start off, I'm going to open up a sketch and I'll draw this on the right plane. And good practice is always to draw about your origin. It will make your life much easier later on. So I'm going to go ahead, I'm going to create a circle about the origin on this right plane, and I'm going to dimension this to 1/2 inch, which is the major diameter of my thread. Now, in this video, we're going to be creating external threads. I'm going to take this sketch, I'm going to extrude it, and I'll just use a nice even distance of 2 inches. So I've got a shaft to work with here, and I'm actually going to cut threads into this shaft. The next part to this activity is going to be create a reference circle on the face of my cylinder, and that reference circle needs to be equal to the minor diameter. So I'm going to go ahead and sketch on this face. I want to make sure that I have 2 circles that are concentric. In this case, both are going to be about the origin. And I'm going to dimension this to the minor diameter of my 1/2 inch threads, which is 0.4056. I don't need to do anything with this circle just yet, so I'm going to exit the sketch, and what I've got is just a reference sketch inside on this face. The next thing I'm going to do is I'm going to create a 60-degree triangle or equilateral triangle that has its vertex piercing this reference circle, and this triangle is going to have to come up even with the edge, and this triangle is going to simulate kind of our cutting tool, as if we were kind of cutting this with either a die or on a lathe. Now, because we're doing a unified thread, we're going to have a 60-degree thread form. Therefore, our cutting profile needs to be a 60-degree triangle. So I'm going to open up a sketch. And this sketch is going to need to be perpendicular to this face. So this face was drawn on the right plane. I'm going to grab the front plane. And I'm going to create a triangle. And I want it to be coincident with the top of my cylinder. And we're going to make it pierce this circle in just a moment with a relation. I'm going to choose Smart Dimension. And I'm going to dimension this triangle in 2 ways. First, I'm going to add a 60-degree angle to the triangle. All right, there, that will create my 60-degree thread form. And I'm going to make a 30-degree angle between the edge of the triangle and the face of my shaft. So that will split it nice and even. At this point, I need to add a relation, so I'm going to select the vertex of the triangle and my circle, and I'm going to choose Pierce. It just opened a weird window on me, but not a big deal. So I've set my triangle that's going to create my thread form. I will exit my sketch. There we go. The next step is going to be to create the helix which this cutting profile will follow. To create the helix, I'm going to go under Features, and I'll find Curves. And within curves, I have helix and spiral. It's going to ask me to select either a sketch that contains a circle or a plane, planar face, or edge on which to sketch a circle. I already have one created, so I can either come out and grab my minor diameter circle or select it from my parts tree. Now, I have some options. We're going to define this. I want constant pitch. my pitch on a unified thread will be given as the number of threads per inch. In this case, for a 1/2 inch, 13 would be 13 threads per inch. So to get my actual pitch measurement, I enter 1 divided by 13. Will give me my value. I can flip directions by checking or unchecking. We want the thread to go through the shaft. Number of revolutions, I could increase or decrease. In this case, I want my threads to go all the way down this shaft. My start angle, depending upon what your default is set at, you may have, for example, 180. You can see it will change where the helix starts. This is very important. We want the helix to start at the vertex of our profile triangle here. So I'm going to change this in 90-degree increments until I get it to fall exactly at this point. So I want to set it to 90, and it will drop it right in there. Again, it might be 80, 270, 90, 0. You'll have to play with that. Now, if this were a right-hand standard thread, we're going to spin clockwise. If it were reverse thread, I would be going counterclockwise. So I want to leave this set at clockwise. And I can select the green check, which will then spin the helix down the shaft. My next step is going to be to run a swept cut using my thread form, my 60-degree triangle, and my helix that I just created. So I select swept cut. Under profile, I'm going to select my triangle. And under path, I'm going to select my helix, and it should give me a preview of this thread spinning right down the shaft. I click the green check, and you'll see it has gone ahead and cut the threads into this shaft. Now, if you notice at the beginning, we have a little bit of a blemish here. This would not physically thread onto something with this edge. So what I have to do is I actually have to add a chamfer to this front edge. Now, typically, that chamfer will always be equal to the thread. So a very easy way to do this is to go under swept cut and grab this triangle that we used for our thread form. And I'm going to select it, go to revolve cut. For my axis of revolution, I'm going to turn on the temporary axes under view and grab the axis of this shaft, and you'll see it's going to spin it right around that axis. And when I click OK, it will create a nice chamfer on there, giving me a nice smooth start into these threads. Right? And I now have a 1/2 inch, 13-inch thread going down this shaft. The only step that would be left would be to add in any features such as a hex head or a slotted screw head, whatever your fastener would require.